Okay. So yeah, please feel free to go and add your comments here at this site. And typically, like we did in the GeoPython course, we can start things off by going over the sort of thoughts on the previous week before we go into the next week's topic. And, this is obviously the first week that we're doing this. So you can maybe think about it as well in the future that, of course, if you have questions and you have things that you need answers to more immediately, you're always welcome to contact myself or Levi and ask questions in Slack or whatever. But you can also think here if you have kind of general feedback about how the lesson went or how the exercises went. This is another good place to share them. So let's see here. Yes, so we're getting some feedback here. Now, didn't get all the functions to work, so need to do them again. Do we get to know how they're supposed to work? Well, yeah, I think in essence, the idea is that we're going to be building up a little function library in this script file over the 7 weeks that we have in the course, adding things to it each week in the exercises or most weeks in the exercises. So yes, it's good then if you're not able to get all the functions to work that we do revisit how to create the functions, how to fix them if there are problems with the functions you've created. I don't know that we'll necessarily do that here during the lesson. I hadn't thought about that. But that could be possible. It might be better if we were to arrange something like in a smaller group or like just one-on-one discussions in Slack or something like that might be more helpful. But of course, the exercise sessions on our exercise session on Friday is really great if you can make it. We have, I think, a 4-hour time block there. So hopefully you would be able to drop in there if you're having issues with the functions. I do understand it is on Friday and maybe you're not fully all the way through the exercise by the time that rolls around, but that could be another place to get some feedback. So maybe we'll come back to that after we finish with the lesson today. We can talk about, for those who are having problems with the functions, how to resolve those issues, because it will be helpful in the future weeks to have the functions and the things from the previous week working, although we don't tend to rely on them too heavily. So, and yeah, a couple comments here about the exercise being a bit long. Yeah, I kind of felt like it was maybe a little bit long as well. I was debating cutting a couple things and decided to leave them in the end. But yeah, I think it was a bit longer maybe than I would have liked. And in part, with creating some of the functions, it's nice to be able to finally end up doing something interesting with them. But the first few parts of the exercise can sometimes take a bit of time. And then by the time you get to the end, it starts to feel like it's pretty heavy and long. So yeah, that's good to know, because I was kind of thinking the same thing, that the exercise felt maybe a bit long, and that's helpful feedback to know that you're feeling the same thing, because then I can consider that for the future. I think this week's exercise is not as long, so let's see come 1 week from now whether you have the same feeling or not. But I don't think it's as long. As far as will you get any feedback before Friday, I think it's possible. I don't know how much feedback you would get before Friday, but at least once the exercise is hits its due date, I can normally run this little automated grading script. And so you'll at least be able to see for all the cells where it should pass some tests, you'll be able to see whether or not you got the right solutions. And then depending on Levi's availability to do the grading before Friday, it may be possible to get more feedback there, but he basically has to go over the exercises and over your responses manually to make sure for certain problems we just can't automate the grading, and he has to get the comments on those. Exercises felt hard in the beginning. It took time, having done GeoPython a year ago. Yeah, I think that's probably, to me, that's not a big surprise, because this is one of the things that's a bit of a challenge now. Previously, this introduction to quantitative geology course was every year, so it would always follow GeoPython. And the majority of people took the GeoPython course and then immediately took this. So there were some things that were just more familiar to them having come right out of that course. I hope that, within a couple weeks, that, things are kind of moving smoothly again, because we don't really go back heavily into things in GeoPython, but like remembering how to deal with data frames and pandas and things like that. Of course, if you haven't done much with Python in a year, that could be a bit of a challenge. So exercise session on Fridays may be a little late. Yeah, I mean, I appreciate the comment. This is one of the things that's challenging in a sense, because previously when we had the exercise session like a day or two after class, people complained that it was too early. And so I understand totally that, Friday is a little bit late. Maybe we could try to do something like have a little question and answer session sometime earlier in the week, like on Wednesday or something like that. I could just have a time where people could come join on Zoom or something like that for some questions in the middle of the week. If there's, interest in that, then that might be a possibility, because of course we can't move the exercise session very easily at this point, especially now that we have a room. I think probably it's best to keep the main session on Friday, although I do understand that, yeah, it is a bit late. So maybe we can try to come up with some kind of solution there as well. Managed to get the Gaussian function to work, never managed to make the data frame with the normal distributions. Yes, and exercise was very long. Yeah, okay. So yes, this comment we've seen a few times. Sorry about that. I suppose, well, so two things. One is I heard that there were some people that were having issues with submitting their exercises and having problems with GitHub. I don't know whether that's true for many of you that are here, but if that's the case, at least Levi said that it might be helpful to remind you where to find the information about how to submit your exercise using GitHub and how to commit changes and things like that. And of course, now that the kind of nominal deadline is 10 minutes ago, it's not so useful to maybe see that information without a bit of time to use it. So I was thinking that maybe it would be useful to give you guys an extra day to, if you were having problems with GitHub or whatever, I could extend the deadline for exercise number 1 until maybe 5 o'clock tomorrow. So that gives you a little more than 24 hours. Obviously, that's going to cut into a little bit of the time for exercise number 2. But if you were having GitHub problems and need some help there, of course, the thing I don't want is that some technological thing is kind of preventing you from turning in the work that you've done in Python. So yeah, I will send a message in Slack about that. But you've obviously, for those who are here now, you can also hear the message that exercise 1 will be due tomorrow. So that's the 9th by 5 p.m. or 1700 hours. And let's see here. So if you were having problems with GitHub, if we go to the GeoPython course page, in lesson number 2, there was this meet Git part of the lesson. And if you go there, there's kind of an overview of what happens in Git, how it works. If you haven't used Git before, this is probably quite useful to read this over. Even if you have used Git and it's been a year since you took GeoPython or something, it might be good just to kind of read through here quickly to refresh yourself. There's some information here about making a personal access token. As far as I've understood, everybody was able to do that. But if you keep scrolling down, there's some stuff about this Jupyter Lab Git plugin. That's probably what's easiest for you to use for working with the exercises. And it shows you how to clone a repository and how to enter your credentials. So this is like your GitHub username and personal access token. And then also some things like how to see the status of some Git repository that you're in Jupyter Lab, how to add things where you've maybe made a change to a file. And once you've added that, how to commit the changes. And then finally, how to push things up to GitHub. So if you were having issues, and even if you weren't, whatever, if you want, a little bit of extra time for this exercise number 1, since it was, as noted, a bit long, and if you have questions, for instance, about the functions, I think my main message to you is that we are very willing to help, both myself and Levi, if you have questions. I'm regularly sort of answering questions from people in Slack. I try to kind of keep an eye on it. I can't guarantee that I'm always able to respond super quickly, but I do keep an eye on Slack and would be happy to answer questions there. So, for things like the functions for this past week's exercise, if you're having issues with that, that might be a good thing to ask in Slack. Or again, once we finish up with today's lesson, we could possibly talk about those kind of things as well. So I think that's the overview here. This is very good to have some feedback, so I appreciate that very much. And I will make note about the exercise being kind of long. I'm aware that it felt a bit long when I was making it, but sometimes that's a bit hard to gauge until people go and work on it. So appreciate the feedback. Any other questions in chat or anything at the moment? I don't see any signs of activity in Slack right now. So if you haven't joined the Slack yet, I would again encourage you to do so, because it is a very good place to ask questions. It's really nice because you can ask questions and then get responses there, or maybe you can just go looking to see if anyone has asked a question that you might already have in mind. But if there aren't any other questions at this point, I was going to go and just say one other thing here in Jupyter Lab. So hopefully you have gone to the CSC notebooks and opened up your Intro QG 2021 instance. For our lesson for today, we're going to be needing this notebooks. Sorry, that's the wrong directory. So Intro QG notebooks and then L2. If you're having a problem with the L2 directory, like it doesn't show up, could you possibly just put a red X, I guess, in the responses in Zoom? I had the problem that it didn't appear for me. This L2 directory wasn't there at first, and I had to fix it. So just want to know whether I'm alone. Okay, so there's at least one other person having an issue here. Okay, so I'm going to go through just quickly. This should be like a one-time thing. I made the stupid mistake of updating the notebooks after I had already let you guys start working on lesson 1 last week, and that was a mistake on my part, which I only realized this afternoon when I tried to open my CSC instance. But if you're having the problem that this L2 directory is not showing up, and you want to resolve that, of course, the way to do it is, I suppose there's actually probably 2 ways to do it. I guess if you were in here in this GitHub or Git plugin, you could do things that way too. But I'll show you the way that I fixed things, which was I went to File, New, and then went to Terminal. So this is going to open up a terminal window. So if you click on that, you should get something that pops up like this. And if you type ls, you should hopefully see the directories that are in the kind of home directory here when you start up one of these instances on the CSC Notebooks platform. So what we want to do is type cd and then intro QG. So we're going to change directories into the intro QG directory. And then I'm going to add a / here and just change right into the notebooks directory right away in a single command. If you do that and you type ls, you should now see that the L1, L2, blah, blah, blah directories. And most likely you're going to want to go to L1 where you'll see the notebook files from last week. Now, if you're having an issue that L2 hasn't shown up, it's probably because if you type git pull, you're going to get a different message than I do. Mine says already up to date, but you're probably going to get something that says that there's local changes to this numpy.ipynb file that would be overwritten by this attempt to pull down the new files. Now, I think it's probably safe because we didn't really cover too much during the lesson that's not on the website to just simply do a git checkout and then the numpy.ipynb file. So this is the notebook. The git checkout command will just take the original version of the file. So it will delete any local changes that have been made since this file was created. Again, because the course page has all of this, all the kind of solutions for this little NumPy lesson on the course page, I think this is totally safe to do. But if you check that out, for me, it says updated 0 paths, but it will probably say it updated 1 path. And then you should at that point be able to type git pull again. And what you should see is now some files get pulled down, and you should also be able to see the L2 directory is now there. So if that's not the case, please say something in the chat or make another red X if you're still having problems. But I think probably that's the main thing. It's possible if you have changed other of these notebook files. Okay, it worked at least for Janna, so that's good. If you have changed any of these other notebook files, you can also do the git checkout command with other notebook files. Lakshika looks like there's still some kind of problem. Do you want to maybe paste in chat like the message that you get when you try to type git pull, or were you not able to get here? I don't know. Maybe you can say something in chat. But yeah, that was my mistake, because if you change something after this has already, like this directory's already been created, then Git doesn't know what to do, because there's local changes to the file from when we did the lesson last week. And there's changes to like a newer version on the GitHub page where it's trying to pull it down. And it just simply says, well, I'm not going to overwrite this. Okay, looks like Ilmar is having an issue here as well. Is it, I don't know whether you can describe that in chat or how you want to proceed. I guess probably Levi is not here. So yeah, if you can say, like, if you're having a problem, maybe you can type a message into the chat and then I can try to respond there. Because I think it should hopefully be a simple fix, but this is a bit frustrating. Okay, Lakshika looks like she's good now. But yeah, it should basically be the case that what happened is most probably this NumPy notebook was changed. Some others may have been, and if that's the case, that's okay. But it should be that you can do git pull. It should tell you which notebooks are causing a problem. And then you can type git checkout and whatever the name is of that notebook. And then it should say it updated some path. And then finally, you can do git pull again, and things should be okay. In the future, this, like, if you fix this once, it should be okay in the future. But yeah, if you're having problems, please just describe that in the chat, and I'll come back there in a minute. But yeah, turning to our topic for today, we're kind of continuing. I guess I should refresh the page here so I can see lesson 2. Kind of continuing in the theme of basic geostatistics from the first week. So last week we really met some largely kind of simple statistical calculations. So calculating a mean, standard deviation, standard error. I think most of the reason I want you guys to do that is just because it's nice to know how those numbers are calculated, not just that you can, do some data frame.mean to get the mean values. I mean, of course, you can probably understand how that's calculated, but understanding things like the standard deviation is maybe a little bit less clear. So that was the point in last week's lesson. And doing things like plotting the Gaussian distribution is also something that can be handy to do for visualizing your data oftentimes. So continuing on with that, this week, we're maybe taking a slightly more data-oriented view, looking at three main topics. And we'll just kind of touch on these because the exercise, you'll have time there to really get into things in more detail. But we'll talk about least squares regressions, which is probably this term itself might sound a little bit unfamiliar, but if you've ever put a trend line to some scattered data, like on an XY plot in Excel, that's essentially what we're going to do, is calculate how to put a trend line to a data set. And then we'll talk about linear correlation, which essentially is just a measure of how well some data set fits a line. So in essence, if we assume that there should be a linear relationship between two variables, the correlation will that'll allow us to calculate and quantify how well those two relate. And the last topic then would be about this goodness of fit calculation, which is another way basically to compare some data to observations. So that's our overall theme, is kind of comparing data and observations, or data and predictions rather, with our Python skills that we have. And so our least squares regression, all three of these are separate notebooks. So we'll start with our least squares regressions. And so for that, I'm going to jump back to the CSC notebooks. And here in the intro QG notebooks L2 directory or L2 folder, you can find the least squares notebook there. And if you could just double click on that, it should open up. And I suppose, the concept is probably already fairly familiar in a sense, but this is one of the ways in which we can determine whether two values are linearly related to one another. So what we might think about as a nice example here would be, for instance, the temperature of some magma versus the weight percent SiO2. So in this case, as the weight percent SiO2 goes down, the melt temperature tends to go up. And we are probably already familiar with the idea that if you have more mafic melts, they tend to be higher temperature. And if you have more felsic melts, they tend to have a lower temperature. And so these two things are variables we might expect to be linearly related. And maybe you have something like 4 measurements, and then you can plot a line here that is showing the relationship between them and how well they are fit. And in this case, being fit by a line very nicely in this example about the eruption temperatures of magmas as a function of the SiO2 content. Not everything in our field looks anywhere near this nice, but this is a kind of textbook example of the relationship between those two variables. Now, the way in which we work with something like fitting a line to our data, so if this is scattered data in some XY space, temperature versus weight percent SiO2, for example, is we first want to consider the idea of how to plot a line in terms of X and Y relationships. And probably this looks familiar from even like maybe middle school or high school math. The relationship between this is basically the equation for a line. So Y value in the line equation here is just some intercept value here with the letter capital A plus B times X, where B is the slope of the line. I know this as Y equals mx plus B from the way that I learned it in math class. But for our example today, we're going to use A for the intercept and B for the slope. And of course, X would be some value on the X-axis. So this allows us then to plot a line for any two X and Y values or any range of X and Y values very easily. So just the equation of a line. Now, in order to determine what our best fit is, we have to think about a case where maybe we know what these values of A and B are. And then we use that to calculate what some value of Y would be for some value of X that is perhaps something that's known. So if this is assuming that we don't have any kind of uncertainties on the values, we're just taking the points themselves, Xi and Yi, for some value of X and some Y. And for known A and B values, we could then figure out what the value of Y would be just from these two, A and B. So the way that these can be calculated is shown here. There's a series of these different equations. And so this is allowing us to calculate what our intercept and slope would be for a range of X and Y values. So let's imagine we had 5 points, then there would be 5X values and 5Y values. And then here we have some summations that are used. That's this kind of capital sigma, which looks familiar, hopefully, from last week. And we're summing up and multiplying different values together in order to calculate A and B that will allow us to then plot a line that relates our two values. So that's maybe sort of abstract at this point, but that's the kind of idea for what we're doing. This is something that you'll do in the exercise for this week to kind of convert these equations into a function in Python. And we might actually play with this a little bit during the class time today as well. But I'll note a couple things here. These summations are occurring for values in some cases that are multiplied by one another or multiplied by themselves, like X squared. So you have to be a little bit careful when you start thinking about how to sum these up, because for instance here, the summation of X times Y would be the sum of every X value multiplied by the corresponding Y value, which is different than summing up X and summing up Y and multiplying them together. So we have to be a little bit careful in Python when we deal with this, and we'll come to that in just a moment. But basically, you calculate A and B like this, and then there's a delta underneath both of them that you can calculate as shown here. And these are going to then give us some line, like a trend line fit to some scattered data. And in this case, this would be for what's called an unweighted regression line, meaning that we're not considering any uncertainties. We're just taking the points and fitting a line that best is positioned between all the points. And it's possible, of course, to calculate weighted regressions as well, but that gets a little bit more complicated. So I think it's good just to start with the simple case here. Now, what I was thinking for today's class is that we could do some kind of demonstrations here that are not really fully planned out in and fully fleshed out in the lesson, but rather just kind of like a flexible thing that we could do where we could come up with some example of something like a data set where we might expect there to be some kind of relationship between X and Y values, like that would allow us to then plot a trend line and see how well our data fit our trend line, or how well our trend line fits our data, rather. So I thought that could be something useful to do. I was thinking that, there's one example that came to mind for me would be to like take, for instance, people's ages and number of years of university that they have completed, just as an example, because it might be something where we would expect there to be some kind of correlation between how old you are and how much university you've done. Obviously, life gets, it's different for everybody. So it's not a perfect relationship, but that's also how real data is in nature. Our geological relationships are seldom going to be that good. So I don't think on the lesson recording, no one can see the chat. If you're okay with it and you don't mind sharing like your age and how many years of university education you've completed, would you be willing to put something like that into chat? And just like, you could also just make up an age if you don't want people to know your real age. Like, don't put 100, but put, something around your age if you want. And then what I can do is I can put this in, like, once we have a small data set, I can fill this into the notebook here. And then we could do some things with the data that we have in our data set, make some plots and see how things look. And then I was thinking, like, after class, maybe I could add these notebook files to the course page somehow, so you could access them if you wanted to. Does anybody have, like, are you guys okay with that? Would you be willing to do it? So you could just kind of put in, like, in the chat, just like age, comma, number of years. So something like, whatever your age is. I don't care if people know my real age. I don't know how much university education I could sort of consider as part of my education, but I guess maybe we could call it 10 years. So if you put in something kind of like this, I do realize that, people could see your name in the Zoom chat. So, you can kind of mess with the numbers a little bit if you want to, but I thought it would be handy to then have a little data set we could play with. And then we can plot things up and see how well our linear relationship works. So great. This is handy. I've got to make my chat a little bit bigger so I can see. And then I'll start filling in things. The nice thing is on the screen here is that nobody can see anybody's name in here. So I'll make a list of ages and a list of, maybe I'll just say years of, and we'll just call it univ. Make a couple lists. And all right, so I'm going to exclude myself just because I'm going to be a bit of an outlier, but then, oops, we'll make a little thing like this. And I appreciate your willingness to play along here. All right, so there's our list so far of the ages, I think. And then we'll go with numbers of years of university. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like we have two lists of the same length. Great, that's perfect. Now we can play. Okay, so we have our two lists, and I think in this case, our expectation would be, for instance, that our X values would be the ages and Y values would be the years of university. And so we first have to come up with our equations here for A, B, and for delta. And since delta is in both the A and B equations, I'm going to calculate that one first. I'm not going to do this in the form of a function just because you can do that for the exercise. So I don't want to totally give away what we're doing here. But we're going to have delta B equal to n times the sum of X values squared minus the sum of X values, and then that whole thing squared. Now, my suspicion is I probably can't get away without importing some things here. I'm going to need at least import NumPy. I'm probably going to need to import matplotlib to do some plotting. Matplotlib.pyplot as PLT. So you've seen these things before. And what I'm actually going to do is I'm going to take our two lists and make them NumPy arrays by just putting them inside the np.array function. So again, this is just kind of like optional stuff to follow along with, but I thought it would be fun to illustrate concepts a little bit more than the lesson does by itself. So we'll put both of those inside of np.array, so that'll make them NumPy arrays. That makes it a little bit easier to do things like some of the summations. So that's the reason I'm doing that. Now we've got n out here in the front. That's the number of values. And well, we know what that is, but we could just simply say len of ages would give us the number of values inside the ages list or ages array. So that's easy. And then that's supposed to be multiplied by the sum of the X values. So those are going to be ages squared. So this is simply going to be ages squared. And what's nice again with NumPy is I can just put this in parentheses. So this is just going to be ages squared, which is what's supposed to be here, dot sum. So with NumPy array, I can do things kind of like I can do in pandas as well. I can just do dot sum to take all the ages values that are here that have now been squared and sum them all up. And then because this n times this thing will happen first, the math will be such that the multiplication takes priority over the subtraction. I don't need to put parentheses around this. Could, but I don't need to. So then I'm going to say minus the sum of the x values and that whole thing squared. So this is a nice example because you can see, for instance, here now we can do ages dot sum. And now I'm going to take this ages dot sum and square it. So that's the difference here between summing up the x values squared. So here I squared everything first and then summed that. So this would take all the values in our list, 34 squared, 22 squared, blah, 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 and then sum them all up, versus here, I sum all the values in the ages list first and then square it. So that gives us the value for delta. If you have questions, I would say feel free to maybe say something in the chat as we go through here, but otherwise I'll just kind of talk about what I'm doing, and maybe I'll add a couple notes in here too. And again, my thought would be that I could share this notebook then after class on the course page or something like that. So let's add some notes, comments in here. Import the libraries we need. That's what we do there. Here we create NumPy arrays with our toy data set. All right. And then here we can calculate our slope and intercept. Intercept. And let's be more specific and call it the y-intercept. So that's where this line would intersect the y equals 0 or x equals 0 line. So what the y value would be at x equals 0. Okay, so we have delta. Now, if we're going to have a little trouble to see what alpha or what a is, but we know it's going to be some stuff times some stuff minus some other stuff times some other stuff divided by delta. So let's start out here and we could just call it a, because that's what it's called in the equation. So first we have to sum up x squared. We already did that here. So it's going to be sum of x squared times the sum of the y values. So I'm just going to take this sum of x squared that we already had from calculating delta. That's here. So it's the sum of the ages values squared multiplied by, should be the sum now of the years of university. So that's just simply years of univ dot sum. All right, that's all we have here. It's just sum of all the y values. So we sum the x squared, we sum the y values, multiply those together, and then we subtract some things here. This time, maybe I will throw some parentheses around here just to make it a bit easier to tell what's going on. So we'll do it like that. So then we're going to subtract the sum of the x values times the sum of the x times the y values. Okay, so sum of x, that's pretty easy. That's just ages dot sum. But then that should be multiplied by x value times y value and the sum of that. So that would be like each x times each y and the sum of that. The way I'm going to do this is take ages times years of univ. That's our two arrays. I've put this in parentheses, this multiplication here, because then I can do dot sum of the outcome of multiplying those two NumPy arrays together. So that will multiply each one of the values. You know, the first value, 34 times 7, then 22 times 4, 22 times 4, etc. Multiply all those together. And in that way, then I can get the sum a bit more easily because I just multiplied x times y and then sum the whole thing. If I put it in parentheses, I can just do dot sum in NumPy, which is kind of handy. Now I'm going to add one more big set of parentheses here to get everything, because now I want to divide this by delta. That should be the value for A at this point. Now we have to deal with B. At least we can see B this time. That makes things a little bit easier. So we got an N out here again. So let's do it like we did last time. Let's say parentheses minus parentheses. So we're going to have this product minus this product divided by delta. So let's just go ahead and add our outer set of parentheses here. Kind of set up the structure. First, looks a little weird at this point, but n, we can just do, again, len ages to get us a value for n. And then we're going to multiply that by the same sum we did, x times y. We had that one right here before. So let's be smart and just go and take what we had, which was this. There's the x times y and the dot sum. Let's copy that and put it here. So len of ages times the x times y sum that we had before, minus sum of x times the sum of y. That's an easy one to do. So that's just going to be ages dot sum times years of univ dot sum. I think going a little bit quickly here, so apologies if you're trying to keep up with the typing, but I think that kind of gives us what we need. We have an A value and a B value. And at this point, maybe what I'm going to do is split things up a little bit, just so that if we have problems, it's a bit easier to diagnose what's going on. So I'm going to run this cell. That'll import our libraries we need. Now paste in our data set. Cut this. Creating our data set didn't cause any problems. And also didn't have any problems with assigning our values of A and B. So it looks like our equations at least worked properly. We can print out now something like, let's do an F string. And say our slope. And our slope in this case should be B. And if I just run that, we get a slope of 0.213, so slightly positive slope. And our intercept, we can also print out. Let's just go ahead and do this as an F string as well. Intercept. And that one's just going to be A. And our intercept is at minus about 0.8. Now, this is fine, but it doesn't really show us too much of what we maybe want to do with our data, which is actually look at this on a plot. So for that, we're going to need to use matplotlib. And I'll do that here using the plt.subplots, and I'll make the fig size a little bit bigger than normal. So let's go with, how about 8 by 6? That's not far off the normal size, I don't think. So I think we've seen this notation before, would have seen this in the last part of the GeoPython lesson number 7, but we're going to create a figure. We're also going to create some axes using subplots, but we're just going to have one subplot. This just makes it mostly easy to refer back to the set of axes for doing our plotting with matplotlib. So let's add some notes here. Create figure and axes. Now we'll plot our data. So we're going to go ahead and do ax.scatter because we have scattered data points. We have ages and years of univ. Those are our X and Y data points. So ax.scatter will plot those We can also do an AX dot plot. And here we're going to add in our line. And I think the way that we should do this is we would need 2 points. So maybe we can just take our minimum and maximum values for the x-axis to give us our trend line here. So what's going to be expected is that you have an x-min or 2 x values to define a starting and ending point for the line on the x-axis, and then 2 y values to define the starting and ending point on the y-axis. So if we did ages.min for our first x value, we could then do ages.max for the second one. And then for the y values, we have this equation back here, y equals a plus bx. We know the x values. So we could then just take our minimum x value and plug it in here with our a and b that we've calculated to figure out what y value would be at that point. So I'm just making here like a little Python list. So you can see the square brackets. And I'm just making 2 values inside there so that I have a pair of, it'll be like 1 x value going with 1 y value over here at the start of the line, and then another x value going with another y value that will go in this other list here. That's the kind of trick to make a line plot if we don't have a data set that we're plotting beforehand, like we're calculating this line based on the scatter data we have. So we have ages min, ages max. Our equation should be that it's a plus bx. So we have a plus b times, and then we just need to figure out what our x value would be here. In this case, we're going to put in ages.min. So we want to say, what's the y value at the minimum age in this case? That's our 1. And then the other is simply going to be very similar, a plus b times now ages.max, because that's the x value that would correspond to this position here. So that'll give us 2, should be 1 item in the list and the second item in the list here. So bare minimum, now we have our scattered data and we have our trend line. It's not going to look real pretty, but at this point we can run this cell and we should get a plot. So here's our distribution. We don't have our axes labeled or anything like that, so it's kind of not so pretty right now, but at least it looks like the trend line here is fitting nicely along with the trend of the ages that we have. So let's just add a couple little things here, because we can do AX, for instance, AX.set. No, I think it's maybe AX dot. I think it's set X label. Trying to remember now. Let's see if I run that with AX.set X label. There's age. Yep. Copy, paste that here for our y-axis. We can say years of university education. And yeah, if we run that already, we have a fairly useful plot. We haven't plotted things like, what the slope is here, but at least our kind of general hypothesis looks like it's true, that for the most part, the more experienced people are, the more university education they have. Of course, there's some variation here. And in fact, I think we can come back to this in the next little part of our lesson. But I think at this point, maybe it's good that we take 5 minutes, just so that you guys can have a little break. And then we can continue in maybe in 5 minutes from now. So about 12 after 3, we'll continue. We'll go through a little bit more of these other ideas for some of the other parts of today's lesson. Then we'll take a look at the exercise. But yeah, let's come back in 5 minutes. And if you have any questions, you can think about those in the meantime, and we can discuss when we come back. So see you in 5 minutes.